Problem 61 asks us to calculate the following to the correct number of significant figures. There usually is an arithmetic operation. In the first one, we're dividing. When you're dividing, we always keep the fewest numbers of significant figures. We have 4 on the first number because it has a decimal place, so we keep the trailing 0, and 4 on the denominator, so fine, we'll use 4. The answer would be 0.2398 grams over cubic centimeters. Don't forget about your units. In part B, 5 sig figs for the first, 4 for the second. Can you see that both the central and the trailing zeros are kept, the latter because of the decimal place? We'll use 4 significant figures. That gives us 12.11 units, grams over grams times, this looks like grams over grams liters. So there's a typo there. This should be grams squared liters, right? Because grams times grams is grams squared. Fine. In the third problem, we're adding. The rule for adding is to keep the fewest number of decimal places, which is interesting, at least I think so for this one, because it's not going to change the answer at all. If you add 0.38 to 12, the raw number is 12.38, but keeping 0 decimal places from the first unit gives us 12 once again. So it does show you how significant figures can pretty drastically change an answer sometimes. 170 milligrams plus 2.785 grams. Well, the units aren't common. We need common units in order to add them. So first switch it. That's 0.170 milligrams. Isn't that interesting? 0.170 grams. Now, since we have a decimal place, all 3 numbers become significant. Okay, we add the 2.785. We're going to use 3 decimal places since that's the least number of significant figures, giving us 2.995 grams. We're adding grams, so obviously we wouldn't do just grams squared, we're just adding them up. 2.1 miles per hour for 3.2102 hours. We would travel 6.74 miles. Notice the 3 significant figures. That's 2 significant figures. I think the correct answer is simply 6.7 miles. So not 6.74, 6.7 miles. 200.1 liters, 4 significant figures, with tons of units there, times 120 liters. That only has 2 significant figures. We'll report it to 2 significant figures. Perhaps more challenging is the unit itself. So we have 24,000 as our number. That only has 2 significant figures. If we put a decimal place, it would have 5, so we don't. Liters times liters gives us liters squared. Atmosphere shows up on the top, and on the bottom, mole Kelvin. That's problem 61.